Last week I kind of hit the limits with this motor. This is the motor that came on this machine, and it's 100 years old. And I'm not exactly sure what happened to it. I was running it off a variable frequency drive.
Let me just step in here, and in the interest of time, I go into sort of an over elaborate explanation into possible theories on what went wrong with this motor. And just to cut to the chase, the motor's dead. And you could tell from my voice at the beginning of this that I'm fed up and ready to move on to something else. What I end up doing is I bought a replacement motor that had some problems. And so I had to refurb that in order to get this whole show back on the road. So now that you're all caught up, we can move on to the real story of refurbishing this motor I bought on Facebook.
And so I'm going to abandon ship on this motor setup. I think, it's fraught with problems and there's a better way to do it. And so I went and bought this motor yesterday from a guy off of Facebook that I've been working with. This is a 5 horsepower motor. It's made by Toshiba International in Houston, Texas. So it's made in the United States. This is, like I said, 5 horsepower. The motor that was on the machine before was 3 horsepower. It cost me $99, basically. I had to drive a little ways to get it. But anyway, I tested it yesterday and it works fine. It's got bad bearings though. You can hear that. He didn't have a way to test the motor, and so I really didn't know what I was getting. In fact, there was a lot of trepidation on even messing around with this option, because not because of the $90, but mostly because it was about like a 4-hour drive round trip, including lunch, to go do all that. And I don't really have time to screw around with something I don't know works. But anyway, it works. I'm going to have to take this apart now and get the bearings out, look and see what size they are, and I'll get some more oil ordered. Also, I want to inspect this fan to make sure that it works and that it turns properly. You can see there's some woodworking schmutz on here, and if it's on here, I can guarantee you that it's probably inside the motor. Anyway, I'm going to take this apart. I'm going to do it on this video. I've got a lot more stuff I'm going to do here with this joiner. I need to get it up and running so I can use it again. But I went through it completely, stripped everything down. There's kind of a saga on that. I'm going to put on a different video, and kind of just another video that just sums up the entirety of this story. But yeah, anyway, so I'm going to go ahead and take this motor apart here. I'll try to do as much of it on film and talk through it. I've almost every machine that I own, I've taken the motor apart, inspected the insides just to make sure there wasn't a bunch of crap in there. And it's really important to make sure you got good bearings. All right, the first thing I'm going to do is open this box and see how it's wired. There's always a little diagram right here that shows what they call the low voltage and high voltage wiring scheme, but basically that switches between 240 and 460. So I don't know how this was wired up. If you take a 460, if you take a motor that's wired for 460 and plug it into a 220 outlet, it'll still run. It'll just be at quarter power, and I think the amperage draw is really low. Okay, just like I was saying, you got these connections here. Okay, so if I'm looking for the 1 and 7 and the 4 are wired together, then I know it's wired for high voltage. So these wires are labeled, and there's usually a number on them that tells you which one it is. Okay, this is the 4. You see it says FOUR right there. The 5 and the 6. You can see it right here. See, it says 6. So in this low voltage configuration, the 4, the 5, and the 6 will be wired together. So this is wired for 220. I'm going to clean all this out, make sure that ground wire is installed correctly. And you need electrical continuity to the actual housing, so this needs to be bare under there. I'm assuming it's going to be all right, but I'm going to check it. Okay, they use these wire nuts, and basically what it is just like a tapered thread insert inside this plastic insulation housing. And the way they install it is you just kind of roll the wires around in a bunch together with a wire knot. That's okay for like home wiring, and like this is very, very common to use these, but I just want to introduce the idea of using these here. I'm going to take this, see this insert comes out. See, this insert is threaded, and so the wire nut insulation has threads on it too, and so it interfaces with this, but this has a little set screw on the inside. And so you could take your straight wires and put this down in here, and then you tighten that nut. And what it does is it allows your wire strands to be straight, so you have all of them in contact, and there's more positive retention on these. And so I feel like you get a much better electrical connection with these. Okay, I went ahead and took that ground off, and you can see what they got going on here. They're just basically butting that ground connector up to paint. And so you're really just relying on the contact through the threads, and the threads are even painted with some kind of primer. This way I get you in there closer. And so there's a couple bare threads, but it's a good idea to like bare the surface on this, even if you have to install this with silicone, just to prevent corrosion. Another thing you might want to do is do an ohm check between your ground wire and the chassis here, just to make sure you have electrical continuity. You know, you don't want to take something like that for granted. I've been shocked before by these machines where you wind up developing short, like one of these nuts will come off, touch the side here, and now your entire machine's like electrified. And if you touch it and there's no ground, I've had a faulty ground here and had a short that didn't trip the breaker for whatever reason, touched the machine, and it knocked me to the floor. So it's definitely not fun. Luckily, that was all that happened. I went ahead and took that box off. Again, going back to my grounding conversation, this here is painted, so you don't have a good electric contact through that. I think it's painted. Maybe it's not, but the back of this is installed with some kind of insulator, or at a minimum primer. So, you know, it's possible to achieve a ground through threads, but it's not a good idea. Then I want to inspect these leads to see how everything is, just to make sure I don't have any problems before I get into this. So now I'm going to take this bell housing off. I'm guessing that's going to come off pretty easy. There's 3 screws around the outer diameter here. These the bell housings are held on with these long bolts, and there's another end of the bolts over here pointing that way. So you take this nut off, take everything apart, and I might have to see how they give you just a little bit of a rebate on the side of that. It's a good spot to use for, like, put a pry bar in there and smack it a couple times to see if you can get it off. There's nothing really. You might be able to install a bearing puller around this outside here to pull it off. My guess is these bearings are shot, and so I think it's probably sloppy and it'll just come off. Okay, this is the little impeller they have in here. It's plastic, unfortunately, and so you want to make sure that none of these little fins or fan blades are snapped off, because it's imperative to have this working 100% so that it's pushing the air across the motor required to cool it properly. One of the things that you need to worry about is this. You don't want to put any like stress on this piece of plastic here. A lot of times they're old and brittle, and so there's a little snap ring that goes on the end of this to pull it off, and you want to be very careful getting it off so that you don't damage it, because if you break this, it might not be replaceable. These holes right here for turning, but you could also stick a puller on here so you can sort of grab around the thickest, strongest part of it and pull it off very gradually. But don't forget that snap ring before you start tearing the motor up. I got the setup here. See, it's coming off easy. I haven't do much to get it off yet, but like I said, be careful. Just turn this by hand. Pulled this apart. You could tell automatically that this bearing is rotten. It's looks like it's gotten hot, and all the grease has come out of it. It's a shrouded bearing, so it's got shrouds on both sides, and inside is packed with grease, but it gets hot, and I could tell it feels a little like, it's hard to explain. You can see that's just burned grease. Another thing is this motor, even though it's sealed, is full of dust, and so I'm going to get that cleaned out. One of the things you want to make sure you keep is a spring washer here. This helps to keep some pressure up against this bearing, and just feeling the surface here doesn't feel like there's any kind of like scoring or pitting. I'm gonna have to take this off with the bearing puller. I'll probably see if I can use that little one right there. But you just want to grab onto it, pull it off uniformly. I've seen people like smack around on using the hammer and stuff like that. If this doesn't come off straight, it could score your little bearing journal there and cause problems. Anyway, let me get this cleaned up. To me, it looks like some of this powder dust here. This is wood. I can smell it. It has like that sweet, like hardwood aroma, but you can tell it's gotten hot because it's like roasted. And I bet it mixed in with the grease that's come out of this bearing and caused it to like coke up. And if you take like dust and debris and mix it with that grease, it turns into like an abrasive. Okay, I went ahead and I was able just to pull this shaft out. Uh, One of the things I've noticed right away is I got a little paint transfer between this rotor and I think my guess is the stator was painted at one point, and so it's probably as a result of these bearings. You can see that's the culprit right there. You see what's happening. Like some of the bearings are gone. The little clips that hold them in are out, and definitely not a good situation. I need to figure out how to separate this bell housing from the rotor here. Again, it's important not to pull this off in a way that's sort of at an angle because you could score the bore on this. Okay, got it. Yeah, these bearings are garbage. I got started here. I'm going to try to do this. There we go. Yeah, man, these bearings are horrible. Looks like the shields of them have fallen off. Something happened here, man. This is not normal. I'm amazed that this motor even worked. They must have noticed it getting bad. I'm hoping this isn't too far gone. Okay, here we go. Okay, this isn't a good sign, but I've got the blue wrench, as they call it. I'm going to go ahead and get the gas going. Okay, so hold on, before I do that, what I have here is I have this under like a tremendous amount of tension, and it's trying to pull this bearing up. It's locked around here pretty good, but I use my impact wrench to tighten this up. I'm going to put some heat right on this inner ring here, and the idea is the heat it'll do two things. It's going to sort of liquefy any kind of schmutz that's in there, and sort of get everything flowing, because grease and stuff like that, like I said, it starts to get abrasive and it'll turn into an adhesive and hold it on there. And then you're going to get like expansion, and so you need to focus the heat on the ring. You'll get the inner diameter of this bearing to open up and let it go, and because it's under tension, it should pop off at that point. Yeah, I was just about to put the torch on this thing to warm it up, and then it started moving. I got the impact wrench set up here on the puller, and it's just gradually knocking it loose. So, and there we go. Man, guys, I don't even know how this motor was working. I mean, I think it's missing a ball bearing somewhere. Looks like one of them came out. Let me see. 1, 2, 3, 4, 5, 6, 7. There's six. There should be either 1, 2, 3, 4, 5, 6. Okay, there should be 12. There's 9 in here, so I'm probably looks like I'm missing 2. It really chowdered up this shaft, though. I'll have to measure this to see if it's round and if it's too jacked up to use. Okay, watch this. This is the other side. Now that I got the inside of this kind of cleaned out, what I'm looking for here on the stator is any evidence of rubbing, and I don't really see. I see a little. It feels pretty good, you know. I mean, it's probably fine. Also, I'm looking for evidence on the installation of any kind of damage. It looks like it's all glued together pretty good, and there's no black marks where I think maybe you had a meltdown or something. Yeah, the wire installation looks all pretty good. Okay, I got lucky. I see the shields here have some inscriptions on it. Made in Japan. NTN is the brand, and the part number is 6207Z. Alright, so that's for this big one here that's complete garbage. You can see the inside of this is kind of polished up. This is weird. I've never seen it this bad ever. I'm really surprised that this thing even turns on.
At this point, I went ahead and ordered some new bearings off the internet. I use Granger usually because they're pretty quick and it's easy to find what you need on their website. In the meanwhile, I did some prep work, get ready for paint. In these 2 photos here, you can kind of see what I did is use a Walmart bag to surround the stator, and then I used some electrical tape to tape around the periphery of the stator, and then I crammed a bunch of paper towels in the recess in between the stator and the housing just to keep paint vapors out. I put this inside of a sandblaster and sandblasted the bell housings and the main body just to knock off all the paint, and then I painted off camera. I generally use a gray primer, rattle can most likely, and then I use an enamel that matches the rest of that machine.
So I got these new bearings in today. I got this one a couple days ago. I ordered from the same company, and for whatever reason, it took an eternity to get this one. But okay, so let me get these out real quick. Okay, look at that. Looks a little better. I got the double shielded for this one, and so it's got oil or grease packed inside of here, so you don't have to screw with it. See what's going on this shaft here. So my shaft for the little side looks very clean. There's some blade marks in there, but a majority of it looks like it's fine. This side is chowdered pretty bad here. You can see there's all kinds of marks there. What I'm really worried about is 2 things. Do I have enough material on this diameter here to properly interface with the bearings so the bearing doesn't migrate? You also want it to be round. If you have any of these high spots here, what happens is you push this thing on and it'll egg the diameter of this raceway, and it'll cause wear. And so if you look inside of here, there's a bunch of material missing from the inside of this, which is bizarre because this is definitely the harder of the 2 parts. This bearing still here is pretty tough.
But I think what happens is you get galling where the two surfaces basically friction weld together. And then when I had a lot of trouble getting this off. The reason why I waited for these bearings to get here is I need to make a detailed measurement of the ID of these, looking at the specs, and then compare it to this little journal here. But I'll make sure to get my fits right. I think you want like a couple thousandths of clearance on, and then you can press fit these on. Anyway, so I'm gonna machine this down. I think probably what I want happening is I'll just take the. I'll wind up reducing material in certain areas because I think I have a high spot on here that just for material wear, and so I don't think I'm gonna have to weld or add material. But anyway, let me get done with that and see how I do. Okay, I got this rotor in my 4-jaw here. Got everything centered on this side. Also checked to make sure I didn't have a bunch of run out on this end. I wanted to favor this side because it's closer to where I'm able to check and closer to the 4-jaw, so I'm going to have less run out. Really what I'm going to do is take like just a few thousandths off of this, mainly just to make sure that it's round, because you can kind of see I already took one pass here. I'll take it out of gear and I'll roll it around. You can see, but yeah, see there's areas like right there where it was sticking out, and you can see a little bit of stuff here in the middle that it's hitting on. And so I'm mainly just cleaning this up and trying to get it to round out again. When I measured it, it was actually an interference fit, which you really want like, at the very most, like, half a thou or something of interference. And it was way worse than that in some areas because the shaft has egged from that galling situation. I'm just going to clean it up, take some measurements, and see if I can get this journal interface to sort of clarify. It's just taking 10 thousandths of material out. It's hardly nothing. Just some fuzz. Okay, right now I'm measuring the shaft is 0.37970, which is right in the target area that I was targeting for. This is basically a chemical similar to anti-seize or Loctite, except it's a medium viscosity, high temperature compound you can put on bearing journals, and basically it helps fill some of these gaps in here and keeps the bearing from migrating. So anyway, let me go ahead and do that. I'm just going to put a little bit of this stuff on here, build it up. I don't want enough that it squeezes out, but I want to use this to hold this shaft in place, or this bearing, I'm sorry. It's probably way too much. And I'll wipe it off at the end. Okay, I got it all over me now, but yeah, so here, I'm going to put some right in here on the inside. Okay, this is the setup I got on my press. I'm going to use this little plate here and this guy here. And then I'm going to set something on top of this, and that'll just push that bearing right down on there. Got this nice, good face here to sort of bear everything out, and it should just slide down on there. Okay, well, there you go. Got this bearing on there. I installed it with that kind of filler adhesive to help keep it on there. There was a 2000s interference fit here. I might have said clearance earlier, but the shaft was about 2000s larger than the bore, and so yeah, I had to use like a little cylinder that was butted up against the surface to push it down. Obviously, you want to make contact with the inner and outer race when you do that press fit operation. You don't want to be pushing here on the sides because it could dent this and interfere with the ball bearings. Or also, if you pry on this outside part, it could like kink it and make it kind of off center a little bit too. So just be careful with that. And I got this guy on here, and so everything's good. I'm just going to basically put it back together. I got the stator housing there, the two bell ends, and then that fan housing. And so everything is just going to get sandwiched back together. Pretty straightforward how that works. Yeah, I went ahead and painted this so it matches the machine while I was waiting on the bearings to show up. I went ahead and sandblasted all these parts to knock the old paint off, and then I primed it and painted it. When I do that, what I do is I take a bag, it's like a Walmart bag, and I use electrical tape around the outside and make sure it's nice and tight so you don't get anything into your coils here. And then I just stuff this outside part with paper towels. And so it's like compressed paper towels like stuffed up in here. So it blocks all these little passages so the dust isn't going to like get in any of the little holes or anything. And so I'll just, all I got to do is pull this crap out later. You can see there's no dust that like gets past this first little layer. And so anyway, I'll pull all this out and take all this off. I might blow it out just to double check. Make sure there's no blast media in there. I also, when I was blasting this, I avoided direct contact with the blast media to this area. This is just like precautionary, so the whole chamber fills up with dust particles. And so, anyway, I've done this a few times, so I'm not. It seems kind of sketchy, but it works. I've done it a few times. Anyway, I'll go ahead and get this back together. So I went ahead and debagged this just to show how clean everything separates. I'm sure some people are going to be super concerned about the idea of putting this through a sandblaster, but it's fine as long as you cover this bag really good. All right, I got this bearing pressed in this housing here. I put a little bit of that dope on there to keep it from having any issues. And then I'm going to put this bell housing on, but I want to put this little ring on here first. And I will, I'm going to do this off camera because I'm working with one hand, but I might have to pop it a couple times with this little mallet here to get it to sit down on there. Got some schmutz there. Anyway, all right, let me do this real quick. All right, I got the end bells on. Everything's tight. I went ahead and painted these bolts just to get the colors. Turns super freely, no goofy noise now. Got the fan back on, little snap ring there. So I'm gonna put that fan guard right there on the end of it real quick.
I went ahead and torqued down all the fasteners and did some touch-up work on the paint, peeled all the masking off, and make sure everything was rotating properly and working good. The next video, I actually test the motor, and it sounded great. All the bearing noise was gone. I take on a lot of these stray machines, and so I've had to do this procedure several times. I thought I'd just take a second to kind of do a walkthrough of what all's involved, and it's pretty straightforward.
All right, I got some new bearings in it. It's spinning 3,800 RPMs.